screen visible first of all? Put yes in chat if it is. Yeah, is screen visible? Yeah, okay. So we'll start and yeah, myself Mayur, and today we'll begin TinyML Arena. Hope you followed the sessions till now and enjoyed Electrobits. So in day we are starting with TinyML Arena, and in this we'll be doing uh, basics of machine learning, and these are like this is what you will be going to do in this week. So today's session is on basics of Python and introduction to machine learning. And then tomorrow there will be the theory will be continued, and then some a model based on artificial neural networks will be done hands-on. Then a model based on sine curve will be done, and then we'll go to TinyML part of this week. TinyML mean basically for now it is machine learning on microcontroller. So you will get introduced to microcontroller in the session in the as the time progresses in the session. But before that, we'll start today with Python. So because all the hands-on things that we will be doing in this week are based on Python. So we are going to do Python, machine learning with Python. So I guess how many of you know Python? Like can anyone tell like Python is interpreter based language or compiler based language? Put your answers in chat. Yeah, yeah, right. Atharv is right. Yeah, yeah. It is interpreter based language, and today I'll give you some basic insights of Python. We won't go much details about the file creating and all, but we'll be doing some basics so that you get used to Python. And we will discuss in detail Numpy and Matplotlib, which are Python libraries that are used in data analysis and machine learning. So you can now go to Google and search for Google Colab. Uh, Please go to uh, your Chrome and search for Google Colab, and go to this website. Welcome to Collaboratory, Google Research. And here create a new notebook. If you haven't created your account, just log in with your account. Create your it is basically using it is a product of Google, so you can log in with your Gmail account. Put yes in chat once you are done with logging in. Once you get this page. I hope you opened Google Colab. If there is any problem, then put in chat. Yeah, I hope you open Google Colab, and now there, go on this option, create new notebook. Yeah, so you'll get a page like this. Here you can rename your notebook as you want, and you can. This is basically for Python 3, and you will have most of the libraries in it, like Numpy, Matplotlib. So you do not need to install it in on your device using pip install and all using your PowerShell. And uh, so we'll start with yeah. Have you opened this? Yeah, I hope you opened this. If any problem, put in chat. Yeah. So we start off with Python. So Python is an interpreter-based language. Unlike the languages such as C++, C, they are compiler-based language. Now, interpreter-based language and compiler-based language, just think as of like Python is like the languages like C and C++ are more near to hardware, so they are a bit faster. Just they are bit faster, like not like they it won't take like if Python does in if C does in 1 second, then Python runs same program in 10 seconds. It is not like that. There is just some millisecond like very less time difference when program is compiled and run by a C language and when a program is interpreted by a by a Python program. So now this time consideration like gets important when you handle huge amount of data. That we'll see. For that we use NumPy, and yeah, we'll begin with Python. So Python is actually referred as the pseudocode for any program. For a C programming language, to just to print a sum, you need to declare in the data type of variable, and then do to print, then printf, then that all stuff like that. And in Python you will like just do a equal to suppose 5 and let's say b equal to 6 to run, and if I want print a plus b, this print is used to do like print whatever is inside this, print a plus b. So to run this, you can click here or just do shift enter, press shift, and while you press shift enter, it will run the program and it will print 11. Yeah, so 11 is printed, and uh, if you do like here a by b, then it will like give you floating point value. Like you don't need to define, like if you do this in C, then it will like give you it will give you 0. But in Python, like it is so smart that it can like consider this. If you just give it a point here and run all the shells again, you can run all. Well, I'll give it here a plus b. See, yeah, here it does like it prints a floating point floating point on its own. Okay, so this is like you can simply print this, and you do not need to close this with like any state to like if you write any statement, you do not need to close with some colon or dot or semicolon as in C. You can do that easily. Now to print a string, you will just do a print and you can just type whatever you want and press shift enter. It will print. Okay, so next we'll discuss some operations like to find the cube, to find like what any guess like what will this print? It is basically square of a number, so it will print like 16. Okay, so and if you do for this, so this will print the integral part. 4 it will print integral part of this. And then if you want to print string many times, like let's say 5 times. So suppose you want to print hello 5 times. So you will write hello. You can do \n for new line, and you can just do *5. It will print 5 times for you. Okay, so till now, like it must be clear to you. Then I'll move on to list in Python. A list. So list is basically like array of you can like uh, uh, interpret as an array in other languages. Just the nice thing about list is like here in list you can define yeah, in list like you need to do these square brackets. Yeah, so in list you will like you need to give store whatever you want uh, in this square brackets, and you can store here an integer, a floating point, or even a string, a single character, even a string like hello. And this is like a list, and if you print list, then it doesn't show error. But if you do this in other languages, then other languages, I mean C and C++, then you can like enter a same type of data in array. You cannot enter a string when you are entering the elements of when the elements of array are integers. So if you print list, it will print 1 2.0 a and hello. Now to access particular element of list, you will pass a argument with the square brackets to it. And here counting in Python or like any language, the counting starts from 0. Like this is 0th element, this is first element. This is 0th element, 1 is 0th element, 2 is second element, oh sorry, first element, A is second element, and hello is third element. So if you do list of 0, then it will print 1. And if you like do list of 3, then it will print hello, and so on. Like if you want A, then it will do you have to pass you have to write here 2, and it will print same. Now actually you can modify list. Like if I do list dot append mean it will add to the end. Like if I whatever I will append here, like it will be added to the end of the list. So list dot append And if you print list, print list now, then see it adds to the it adds high to the end of the list. And if you do list if you like want to insert some number between the list, like something in between, then we have to do list. Yeah, modify from modification. I remember, like if you do list 0 equal to 2, then and print list, then print list. And like see, this is like modified with 2. And like if you want to modify list, like if you want like specific this is like basically called slicing. So if you want specific elements of list, like 2 as to 4, let's say, there are so it will print second and third element and not fourth. Like it will print 0, 1, 2, and this is like this will print A and hello. So yeah, so that's what you should you like basics of list and all. And another type is called tuples. This is basically a list which cannot be modified. You can do same here, but 45. You cannot modify this. Suppose like I do if tuple of 0 equal to some number 8, then see it shows error and the program won't run also. Won't even run. Yeah, so these are what tuples. And yeah. Now I'll go to delete this cell. Yeah. Now I'll go to the conditional statements. If statement, if and then statements, like if something, then let's say yeah, like corresponding to scanf function. Just a minute. Yeah, okay, I'll continue. So tuples cannot be modified. Now I'll move on to if statements. So suppose you want to input some number to your suppose you want to take a number from user and store it in a variable. So suppose I'll store it in a variable j equal to input, and based on the j I'll print something like if j is like smaller than 3, then here you have to just give semicolon. You will come to the space here with this, and it will start with here. So this whatever you will write from this cursor, like below this cursor, it will be included in the if statement. And if you like write from here, then it won't be included in if statement. So yeah, I will start with here. Then suppose print j is smaller than 3. So this is like I'll exit out of this, and I'll do elif, like else if j is greater than uh, or equal to 3, let's say. and you'll use semicolon and greater than or equal to 3, and else you'll print is smaller than, like, you print j. Like this else statement will work, like it is just for a demo. Now we'll ask, it will wait for input when I enter file. Okay. If j is smaller than 3. Restart once. I'll restart once all the cells. Yeah, sorry for disturbance.
Mayur,
Yeah,
uh,
yes, yeah, I got it. Like, I should convert when you input here anything, like it is like basically string, and you are like comparing a string with numbers, so that's not valid. So you'll put int here, like whatever you are basically inputting here, that will be converted to string. Now whatever you input here, like if you input 5, then it will be a string. If you print enter, shift enter. Yeah, see, j is greater than 3, and other statements are not printed. Okay, so yeah, that's what about if and else statement. And there are also loops here, like for loops for some, like in range 0 to 10. Wait, here also you have to give semicolon, then print I from 0 to 9, like it excludes this number. That's all. And yeah, for and in this I'll also do break and continue statement, like if your I becomes equal to 2, then break out of loop. And it should break out of 2. It will print 0, 1, and after 2 it will break. And if you do continue here, it will yeah, if you do continue, after I becomes 2 in this loop, it will continue continue the iteration. Like if I becomes 2, then it won't print high, and like uh, it will start the next iteration of loop, like I equal to 3. Yeah, so yeah, see at the second iteration, it won't print high. Yeah, so that's all about basics of Python. And now we'll start whatever is most important, like much importance to our week. And what we are going to do now is NumPy. So NumPy is like same as arrays, but these like have this. Uh, this is basically array, like same as list, but the main differences are like NumPy is with NumPy your calculations are much fast, because NumPy is a library which is like most of the part is written in C programming language, and most of its like functions and all are coded in C, so it is bit faster than list. Uh, the thing is, like in list, the address allocation in the memory of your device is like random, but with in NumPy, the memory allocation, like it is like continuous as in C programming, like with difference of 4, with difference of like if you would have done in C programming that addresses and all. So address is like difference of the data type, data type of the array, data type of the array element. So we need NumPy when you handle big like many like huge amount of data, when you like when we have to like deal with some 2D arrays of data and all. So yeah, so NumPy is like uh, more efficient and faster way to analyze data that we are going and that we'll start off with now. So you have to import. Yeah, so are you following till now? Any doubts?
I don't think they have any doubts up till now.
Yeah, okay. Yeah, okay. So I start with NumPy. I'll import that library NumPy. Import NumPy. And NP is like the way you want to import. Like you will be using this for all your instead of this NumPy and all. Like you can write anything like NP, anything, like you can write anything here. But with let's go, like most of the developers and all, they will use NP as like they will import NumPy as NP. So we'll include this library, and then to create a NumPy array, we have to write. Let's say that array name is my array. Let's see there, to create a NumPy array, you have to write np dot array. The argument you pass to this is a list. Let's let's say it as number 1, 2, 3, and 4. It's let's create a two-dimensional array. One and 8. So this is my array, which is like now numpy array, and it has two arguments. It has one argument, a two-dimensional list. Okay, so this is the first row of the array. This is second row of the array, and the row counting like it is from 0 and 1, and here the column counting is from 0, 1, 2, and 3. Okay, so if you want to access a particular uh, element of this array, then you will do just my array of same as how you want to access the element of list. Like if you do 0, 1, and you do shift enter, and it will print my array of 1. Indices must be integer or not tuple. Okay, so but yeah, we'll do that later. Yeah, we'll discuss, like you can also allocate the data type to this array, like d type equal to float 64. So if even if you have like given integer inputs to this, you can array of 1, and it will give you like floating point numbers. D type equal to float 64. Oh, I didn't give a comma here. Shit. Have to look. Hello. Yeah, yeah, it is result. Yeah, so sorry for that. Yeah, float 64. You can also do, like you can also like customize the way you want to store the array elements, like the way the data type you want to store these numbers in. So if I do here int 64, then it will print as integer. basically, and to access a particular element, suppose you want to print some particular element, so it will print the element in 0th row and first column, that is 2. Okay, so now let's move to like the generation of like yeah, we can print the shape of the array like with this, like my array one dot shape shape. It is like 2 by 4 matrix now, so it will print the shape of array. You can access the data type of array by my array dot, it is int 64, so it will print my array of 1. Yeah, so it will print the data type of the array elements you are using. Okay, so moving on. Now we'll go to like how you create one numpy array. So let's say my new array is a1, which is a1 equal to np dot zeros, np dot zeros, and you can give in you can like give the 4 comma 5, so it will create a array with 4 2D matrix of with 0 element. Like if you print a1, you can see it has created a floating point array of with all elements to zeros. Even if you want all elements once, then you will get once. And if you want an empty array, then you print some random numbers. Yeah, like it is not like always 1 here. It can be anything random. You can also specify the data type of array. Suppose you want ones. Or int 32, whatever. D type. Yeah, so the points are like the decimal points are removed and you get the data type and all of this. Okay, so moving on to like, also you can create a identity matrix. Like if you do a2 equal to np dot identity. Yeah, this will obviously a square matrix, so you will pass only one argument to this print. Let's don't store it in a variable, just print it. Yeah, so you can see that we are like creating matrices and all, like a null matrix, identity matrix. So you can find this application mostly in matrix algebra. So NumPy is like uh, well well known for, like it has functions for which can do like directly matrix algebra for you. Like suppose you want to I'll generate one more matrix. Let's say my array of 2 equal to my array of 2 equal to np dot array. I'll again create a 2 by 3 matrix with some random elements, like let's say 2, 1, 3, and 4. Uh, because it is array. Yeah. Okay. Now, if I do my array of 2 plus my array of It will print the sum of all the elements, like elements, but like it will do 5 plus something. Yeah, so it will print the sum of the elements of array, and do like any operation with this. Like if you do minus, then yeah, keep in mind that order must be same. Yeah, disturbance. Yeah, and also do multiplication. You can also do division. This will like do element wise division. Okay. Now we'll do some matrix like the dot product, the cross product and all. Before going to that, to do a transpose of matrix, like an array, you will do my array of one dot transpose, let's say. And it will do, let's see, it will do transpose of this array 1, 5, 2, 6. Yeah, okay. So, and while doing matrix multiplication, you can do NP, you can do that NP dot means the simple matrix product, and you will pass argument to this like my array of 1 comma my array of 2, my array 2. And now you have to give one, you have to of this, because you cannot multiply like matrix with 2 by 4 matrix with 2 by 4 matrix. Like the number of columns in first matrix must be same with the number of rows in in second matrix. So you have to do transpose of this, and it will print for you. Yeah, it will print for you a 2 by 2 matrix, which is like just a matrix multiplication of my array of 2 and my array 1. Okay, so moving on, you can also do cross product. Now cross product here is like uh, row wise. It is row wise. Suppose like it is row wise cross product of vector. Let's say, yeah, this is my array of 2 and this is my array of 1. Okay, so right, my array of 1 and this is my array of 2. Just control copying and pasting. And what it will do is it will like do cross product of first row with first row of this matrix. Like it will give you a 2 with like, see, like it will do cross. I'll show you my array of 1 comma my array of 2, and when you do shift my array of 1 and my array of 2. And it got cross multiple. np dot cross my array of one. It seems like some print this. Okay, I'll come to this again. This is just cross product. And yeah, we'll now move to slicing of arrays. So I'll create one new array, AR, let's say one, np dot array dot array. Let's say again I'll create one. Uh, let's say some elements like numbers. Again, to access some particular elements of array. So you will do 2 as to 4. So it will print like 2 as to let's say you go nothing. So it will print except these two elements 5 and 4. 6 to 8, 9, 92 and 56. So this way you can slice arrays. Slice mean yeah. Now if you store this in an array, let's say equal to would do AR2 of 0 uh, equal to, let's say, 66. And now you print AR1, then any guess like what will be answer for this? Any guess like what it will print? Any guesses? Actually, it will like get modified. The second element will become 66. If you know, like in C programming, the arrays were like the basically pointers. So what happened is like AR1 is like pointing to these elements of array. Okay, you are like just cutting a part of this array. Like you are like AR1 is AR2 is like an array which points to these elements of the array AR1. So modifying this will modify this to like AR1. Modifying this with like 66, it will modify the array. So if you don't want to modify this, then you will do just copy. And now it won't. Now it doesn't like modifies. So Yeah, it is like if you want, if you can like modify the array if you don't use copy function with the help of another array, because it points to that part of array. You would have know that basics of like pointers, like it is pointing to this mean whatever you change the whatever you do in pointer, it is also done in it is basically it is done in that memory address. Like it will be changed here like 6. So with dot copy, it is just copied. Dot copy, just it is just copied, and it won't affect your main array. Yeah, so that was important. Then I'll go to sorting an array. Before that, I would like to define use the axis of array. So let's say we get an array A1, let's say, and np dot 2 by 2 matrix 1, 2, 3, 56. Also 8, 23. So what is axis of array? So axis of array is the suppose yeah, I'll show you. Uh, if I want to do like wait, I'll explain axis you first. So axis is like the alignment, the direction in which like row and columns are aligned. Okay, so row and columns are aligned in the sense if you do axis 0, then it says that it is column. They are columns here. If you do axis 1, then it's like this axis. Rows are the axis 1 implies you are like doing rows. So suppose I want to find the sum of like axis. So let's do that like A1 sum of A1 dot sum of axis equal to, let's say 0. So it will give you a 4-dimensional a 1D matrix with 4 elements, because axis 0 corresponds to columns. So it will do some of these columns this way, like 48 plus 88 plus 12 and 56 plus 23 plus 18, like this. Yeah, see, it does so. And if you do axis of 1, then it will print like this way. Okay. Uh, you can also extend this to a 3-dimensional matrix, but we'll do that at end, like just for we will mostly use like 2-dimensional matrices. And now what we can go is, yeah, sorting. So suppose you want to sort this matrix, like sort the elements of this matrix. Okay, so A1 dot, you will write A1 dot sort A1 dot sort, along which axis you need, like axis equal to, let's say 0. I want to sort about the axis 0. So what it will do is axis 0 mean it will sort along the rows, like 12 will go here, and I'll print let's say array A1. So yeah, see it is sorted like 12, 48, 88 and all. If you do it axis equal to along the rows, this will like it is sorted. Well, okay, we did first that sort along axis equal to 1. So yeah, it is sorted along the rows because wait, I'll do that again. Mm, uh, I'll run this cell again. Yeah, it is like taking that modified with axis 0. Okay. Now I'll again run this and I'll do now axis 1. So it will like do along this axis. See 25 comes here, 48, 36 comes after that, 48 and 56, and same for other rows. Okay. So you can also like specify a sorting algorithm like uh, type, I guess, love it, type. Yeah, kind of. Yeah, kind. With kind, you can sort with the kind equal to, let's say, merge. There are some sorting algorithm like merge sort and what are like merge sort, and merge sort. You can like, yeah. Do you remember any sorting algorithm? We did it in C programming. Any sorting algorithm you remember?
Uh, there was that bubble sort then.
Yeah, bubble sort, more selection sort.
Yeah.
Yeah, right. So it depends, like it depends on you which sorting algorithm you want to use. You can do, I'm using merge sort here. You can do selection sort. I don't know what is syntax for it. Selection. Yeah, it is like basically sorting algorithm, and like difference is just of some time. There is some time difference. End results are same. Okay. Uh, Now after this, we'll do like we'll we'll do arcs. Now again, I'll redefine this array because it is used. Yeah, are you guys following till now? Like, are there any confusions till now? Because of much disturbances from my side. Any confusions or uh, any anything you are not following? Any doubts till now? Are you following? Okay. Uh, yeah. So okay, A1 equal to p-lot array. Yeah, I have defined array. Now we'll do arc sort. It won't sort, but it will say that which element should come to like which number. I'll give you like one example. Suppose you want to do np dot arc sort A1 equal to 0. Then what it will do is like see, it will this is the zeroth element in the first row. Okay, zeroth element, first element, second element, third element. Similarly, this 0, 1, 2 and 3, and again this is row wise. In column wise, this is zeroth element, this is first element, this is second element, and like so on. So if you do np.arg sort along axis 0, it will like show you like uh, in what way this number should be aligned to get sorted in ascending order. If I print this, see, like this number must come at 0th position. So this number must come at one first position when you are like when you have sorted the array. So wait, a1 dot axis equal to 0. And why is it printing so? Comment this out. Yeah, sorry, I didn't show you how to comment. Like this is like if you put hash line, you can form single line comments. I'm running it multiple times, so yeah, it might like show some different result. Because the thing is like in here you can run any cell as you want. Like this, suppose like this cell of your program may run like before this. It is not like same when you write in IDE or some uh, as we used to write in microcontroller, we can your digital design maybe there like it was like it used to print in line, but here like we can control where and what we can where and what we can print. And to give multi-line comment, you can do this. Okay, so like here in Colab notebook, you can print like you can do any you can run any like any cell before any another cell. Okay. Oh, okay. Let's see now it works or not. Restart and run on. This will what this does is like it will run all the cells in line. Mm, still it is doing so. Yeah, so basically arc sort what it does is it it shows you like in the way you should sort that. Okay. And if you change the axis here, like it will show how the way you should sort in like this here. Like the third number is the biggest number, so 56 is here, and this is the smallest number. So it will like if you sorted it says like if you sorted your array with this like with this arc a1 sort, then the zeroth element this is the zeroth element of that, this is first element of that, this is third element of that, and so on. Okay, let me check if anything is remaining. Yeah, argmin and argmax. Okay, what is argmin in p dot argmin? Here also we can define axis is equal to 1, let's say. Now what it will do is np dot argmin axis equal to 1. So this will like give the index of the minimum of these numbers. Okay, so it will basically give you a 3 by 3 matrix. one 3D matrix, like see the arg min. So the second element of this is the minimum in the first row. The second element, again, the second element in this row, the second element of this row is minimum. And yeah, the zeroth element of this row is minimum. Okay. For moving on. Similarly, arg max. 103. See, argmax means the first element, this one represent that the first element of this row, that is 56, is the maximum, and zero is the zeroth element is the minimum. Sorry, zeroth element is the maximum in second row, and third element, that is 63, is the maximum in uh, third row. Similarly, you can do that for axis 0. So it will do it column wise. Same thing, just column wise. Like this is the maximum, this is the maximum, so 0. This is maximum, 2, so 2. This is maximum, so 1. So in that sense. So np.arg min, np.arg max. I hope you are clear with. Now, what else we are remaining with? Yeah, reshaping an array. I again forgot to tell you, like you can create one array with like yes, suppose you create an array a2 with np dot a range comma 18. Okay. Let's give 19. Yeah, we'll give 18. Okay. So what this will do is it will create an array starting from 0, like a 1D array whose first element starts with 0 and the last element ends with 17. Let's print this array. Print a2. Okay, see, so first element starts with 0 and the last element of this array is 17. Now, what is array reshaping? This is important and you will be doing it, yeah, most probably tomorrow and also in sine wave model. So to reshape, a2 dot reshape, and you have to give the dimensions of the matrix you want. Now see that if your matrix has this, yeah, if your matrix has already 18 elements, then the array reshaping takes place when you give a valid argument here. Like 6 by 3 matrix can hold all these numbers. You cannot give like 6 by 5 matrix and all. It will give you error. So 6 by 3 you can do, or you can do 9 by 2, and this will fill row wise. Let's see, like the 9 by 2 means it will have 9 rows and 2 columns. So it will like go like the first row will have 0, 1, then second row will have 2, 3, then 4, 5, 6, 7, 8, 9, 10, 11, and so on. Let's print. See, array dot reshape. If you do print like this, and if you do 6, 3, it will print like this, and 3, 6, and if you do some 6, 4, then it will show you error. Numpy. So yes, I'll share this. Okay. Shape, reshape, and yeah, okay. Most of the things are done. Now, just to give a try, you can find some, if anything is missing, like any doubt, I have like, I'll share with you a well commented this notebook. You can check from there. Like there are comments for everything. So if you are like confused with whatever happened with whatever like done today, you can refer that. And for just for fun, you can like try that axis thing with a three-dimensional array. Uh, One example I have given in that notebook, so you can go there. Okay, so with this, I'll now move on to Matplotlib. Uh, Now, why do you need Matplotlib? Suppose you want to represent your data using Python, you use Matplotlib library. So Matplotlib is like um, with it is said that with Matplotlib and NumPy you can replace MATLAB, one paid software. So to start with Matplotlib, we'll do some simple plotting like I'll show. Uh, so to start with, we'll do. Yeah. Before this, are you following till now? Any doubts? Anything like confusing? You won't like you haven't understand. Can I move on? Like, have you understood whatever like taught till now? Whatever we have covered till now. If you have any doubt, like I'll share this slide here. You can see like there is a comment for everything. You can refer this. I'll share it in slides. Uh, yeah, any doubts? Can I move on? Are you following?
Yeah, I guess they are able to follow.
Yeah, okay. We'll move on. Okay, so to start with, we'll do percentage matplotlib to do for running matplotlib on Google Colab. And because you are using a browser, well, you are doing all this in a browser, okay? And yeah, matplotlib inline and np dot sorry, I'll import matplotlib now. Import matplotlib dot pyplot as pl. Any compile error? Yeah, it successfully compiled. And yeah, with the matplotlib, we'll move on to also will yeah, we have to import a numpy if we need numpy as np. Okay, import numpy as np. Then okay, now I'll define one array. Let's say x equal to comma. Let's give it in increasing order. So, and y equal to np dot array. Let's say some random number, some 5, 56, 89, 92, 5. In any number like will work. Now I want to plot this x and corresponding y coordinate like 1 comma 56, 3 comma 92 on a plot. Okay, they are unequal. I have to give one more. Yeah, so I have to plot this on a I have to you have to plot, you have to describe this data graphically. So for that, you will do plt dot plot. Again, plt is like what you used here. Whatever you use here, it can be used here. It should be used here. Plt dot plot. Now, uh, the arguments for this will be x comma y. The matrices, these two numpy arrays. You can also pass list, but when again when you handle millions of points, like when you will start handling some 1000 points in upcoming sessions, there you using a numpy array is like more feasible than using list, because numpy is like, see, thing is like you can access anything well if it is organized as numpy using C binaries and all. You can access the elements of numpy more with more ease as compared to lists in Python. So that is always like better. And lt.show, but it is like not required. It is like inbuilt in Google Colab. I will not use it. See, so yeah, it plotted something. Yeah, it is like because of the coordinates we gave. Yeah, so this in this way you plot a graph. So, and also you can give title to your plot with plt.title. Plt.title, you will always give a string. Uh, graph, yeah, graph. You give your label, X label, like what is your parameter, like what is your variable on x-axis. Let's say it is, let's write x-axis and plt dot y label similarly. Oh, it is like give y-axis. I'll run it again. Plt dot x label, plt dot y label. Oh, y label, okay. That will print. See, you got y-axis, you got graph as title, you got x-axis. Now you can also do like doing, if you want to plot two different graphs here, you can do that also with the x. Let's say this is another set of points. Let's say x1. Basically, you do this while when you want to compare some. Suppose you want to like compare the earnings of your company with the earnings of other company, or the way the profits of your organization is increasing compared to other, like when you when it is uh, we do this when we need to compare some data graphically. So 423 some, yeah, random numbers, and 9 8 14 and something 16 set of. Basically this list will be replaced by data. Okay, basically I keep it in empire. If here it is completely fine if you like use it as a list, but better doing it in an empire. It is a bit faster when you deal with, again I'm telling, when you deal with multiple like chunks of data. So I'll do again 4 5 9. And now if I want to plot this again, I have to write plt dot plot. Y x now, sorry, here x1, what I'll write here y2, x1 comma y1, y1, and okay, I'll print this first. Oh, I didn't do. Okay, so like this is one of the plot, and if you want to plot x comma y also, plot plt dot plot, and both the graphs for you. Okay, so this is like good for analysis. And suppose you want some only one graph, then you can do erase one with plt.clf to only plot this plot corresponding to this and not that. A plt.clf, like it just uh, plt.clf, it will clear the graph and do the next plot whatever you want. Like if you insert it here, plt.clf, won't print anything. Okay, yeah, that's all. Is yeah, labels for your plot. Okay, y1. If you give label for this, label mean name like uh, when you, like there are many, suppose there are like many organizations you want to compare with. So you give some label to that organization. Let's say this is for this plot is corresponding to organization 1, and this is something related to organization 2. Do shift enter, still it won't plot, like, but when you do plt.legend, show like an index here, organization 1, this orange line stands for organization 1, and this starts for organization 2, like that way. Okay, now I'll do plt.clf. Do it on another page. We'll copy this. Okay, now we have done plot, like it will like join all the lines with in order, like 1 comma 5 6 will then 3 comma 9 to 92, then 5 comma 5, then 7 comma 8. Now similarly you can do a plot named scatter plot. Scatter mean, yeah, you can do it, shift enter. Scatter plot mean just representing by points, not connecting the lines. You can also plot this. Yeah, okay, I'll do scatter. See, you can see this as a scatter plot, and definitely you will be doing this scatter plot in your sine wave model. Uh, so yeah, any you can also set, yeah, one more. You can also set a line width. This, let's it is like scale to 1. Like if you do 6, then it would be like much thick line width. Okay, it will give point width. Like sorry, point, not point width, point diameter. See, like you can also vary the thickness of the plot you make. Okay, also you can do some styling like the background of this graph, like um, uh, boat style, boat style, and the style. But use this is one of the style you can see the documentation of Matplotlib for that. I'll show you that once. STYL style, sorry, style ggplot. Style.use. I guess it won't run all once. Restart and run all. Yeah. Why isn't it giving background? Yeah, okay. Like that is not much important. That is like for just for style and all. Okay. Now one more type of plot I would like to show you. Now I'll create one array. Mm, let's create one array. AR2, AR9, let's say, and AR9 equal to np dot a range from 0 to 256. Okay. Now this will give you 256 elements from 0 to 255. Like the last element of this array will be 255 and first element will be 0. And and if you do AR 9 dot um, 256 element, I'll do 16 by 16. Okay. Okay, so it has printed this 16 by 16 matrix. Now what I'll do is plt.mat show AR9. Oops, probably this argument. See, this is not obviously a rainbow. The thing is like you will be using this tomorrow for detecting a handwritten number using your ANN model. So what actually this is 255 is like the brightest color like that. More the number, more darker is the light color. See the darkness goes on like increasing darkness, the bright, not darkness, the brightness of the color goes on increasing as you go along the row and the color goes on changing as you go along a column. Okay, so let's see if we are remaining with anything here. Yeah, okay, see that with ggplot you can get this background. Okay, with ggplot you'll get this background. Okay, again I'll share this with you. in in uh, in slides, and there from there you can refer and revise, because what important was is the and NumPy and Matplotlib. These are there are many libraries in Python, but you can like. Also, I want to show that NumPy has so many functions. Diff of NP. I guess it will work. Mm, run on. Yeah, this is not good. Diff, like there are like some 600 functions in NumPy, so obviously you can't remember all those functions. So there are like documentations of this respective libraries. NumPy documentation. Here you can like, whenever you need some function, you can search here, and similarly there is a documentation for Matplotlib, where you can, if you want to explore more, you can uh, try plotting histograms and all. That is for further studies. I have like covered most of the things that you would require for the session, uh, the upcoming sessions. Yeah. So I hope everything till now was clear. Put yes in chat if it uh, it was clear to you, and any doubt, also please ask. Mm, yeah. I guess you. Yeah, and sorry for the disturbances that you faced today because of me and some compilation error. Uh, okay, so I guess this will be okay. So now having like get introduced to the basics of NumPy and Matplotlib. Now we'll listen to some theory by Pratyush. He will tell you, he'll introduce you to machine learning, what machine learning is, and yeah, okay, thank you. I'll stop sharing, and there is like we'll have a break for 2-3 minutes. After that, you can Pratish, you can start sorry, machine learning. Yeah,
Hello guys, am I audible?
yeah, Pratish, like you can wait for 2-3 minutes.
Okay.
You can share your screen and give them a break of 2-3 minutes.
Uh, no, it's fine. Let them have the break. You know.
Yeah, I guess Pratyush, you can start.
Okay. Like, is everyone here? Uh, I guess everyone is here. So that was a great session by Mayur. He almost covered everything that we might need for from Python for ML. Uh, Hope you guys also enjoyed that session. Now let's get started with ML. I'll just share my screen. 1 minute. Can you see my screen, Mayur?
Yeah, it is visible.
Okay. So we are starting with machine learning. So what is machine learning? Machine learning is an application of artificial intelligence that provides system the ability to automatically learn and improve from experience without being explicitly programmed. Now, it's really a complex definition here, but machine learning is actually very easy. So, what machine learning is that we teach a machine to take decision based on past experiences. Yeah, that's all is machine learning. You can see an image on that, right? We give training data, that is we give some data, let's not name it for now. We put it in an algorithm. Our algorithm builds a logic around that data. Then let's say I gave some unknown data, like I want to know about this data. So our algorithm will use that logic and give us output. So what is that output? We'll learn that uh, in coming sessions. And okay, now that we have answered what, let's see why do we need machine learning. uh, Machine learning has wide scale application. It's used everywhere where large scale data is required, like anywhere where we have too much data and too much unanswered question, we'll use machine learning. Social media, virtual assistant, e-commerce, etc. These all are just some places where machine learning is used. There are more such fields where we need machine learning, and actually we don't have much time now, so let's continue with machine learning tomorrow. We have answered what and why. Let's start with how from tomorrow. I hope you guys enjoyed intro to Python today. We'll continue with ML tomorrow, and we'll also see one model uh, of machine learning tomorrow. So let's end this session for here for today. And guys, at least answer something in chat tomorrow. Don't be so less interactive. Okay, bye. Yeah. Okay, we'll continue with ML tomorrow. Mayur, you can end this meet, I think.
Yeah, sure.